Between Missoula and Sandpoint, the Clark Fork River squeezes through the rugged vertical-walled canyons. Anywhere canyon walls close in, the rushing river increased speed. Imagine the canyon narrows, or gorges, as a giant hose nozzle formed by cliffs, spewing 500 cubic miles of water, 60 times the flow of the Amazon River, along with rocks, debris, and silt through the gap. The sheer force of the flood scoured the vertical rock faces, leaving grooves in the bedrock 340 to 400 feet above the river. The sheer power of the event at Eddy Narrows, for example, is mind-boggling. Boulders shot through the gorge without bouncing off the river bottom at the top of the cliff face, just like cannonballs from a cannon. What must it have been like? The evidence left behind helps describe it.
Eddy Narrows is where all 5 arms of Lake Missoula finally came together, and all the water had to flow through this point. This makes it the best place to measure the flow rate and the speed of the water. At the flow rate of Eddy Narrows, the lake could empty in about a little over 2 days, and it determined the character of much of the rest of the flood, how big the other temporary lakes were. So it is really an important item to be aware of in the flood.
Narrows are basically anywhere where you have a stream channel, and that channel gets forced into a smaller area. And a great analog to this is we've all taken a garden hose, and when you don't have your thumb over it, the water's pouring out really slowly. And then when we put our thumb over the garden hose, that water sprays out very fast. That's because you're forcing the same amount of water through a much smaller area. And so a narrows is exactly that in a stream channel. We've taken a large amount of water and we've forced it into a small area, and it becomes a bit like a jet nozzle. And that water's forced to move very, very fast in order to move the same amount of water through this small constriction. And so when we have narrows, that's where the whitewater is. When we talk about narrows of Glacial Lake Missoula, then we're talking about narrows at a whole nother scale. When the lake flooded, the river was about 2 kilometers wide, or 2,000 meters wide. That's a little over a mile wide. So you've got to really just expand everything you know and think that you've observed in a river at 100 meters, you got to multiply it by about 100. So it gets about 100 times wider and about 100 times deeper. But we're still in a narrows, so we're going to have rapids, we're going to have waves, we're going to get a lot of the same things we see in rivers today, but they're just much, much bigger. Almost all the roads in western Montana follow the river course and would have followed a natural drainage pattern of Glacial Lake Missoula. Anywhere where you see the sides or the mountains close in on the freeway, that would have been a narrows anywhere around Missoula. Right now, you enter Alberton Gorge, which is a modern day narrows. Alberton Gorge, the walls of the river close in, and where that happens, we increase the speed and depth of the river, and we get these big rapids. And that's where people go to play in the river and get in whitewater today.
Curiosity and imagination help drive the scientists to interpret the ancient events and understand the present-day world a little better. If you're curious, explore Eddy Narrows or the Alberton Gorge to see firsthand the power of the Ice Age flood. Take a selfie and post it on Instagram with #Montana Natural History Center.